Tree in data structure. The tree is a nonlinear hierarchical data structure and comprises a collection of entities known as nodes. It connects each node in the tree data structure using edges, both directed and undirected. The image represents the tree data structure. The blue color circles depicts the nodes of the tree, and the black lines connecting each node with another are called edges. You will understand the concept of tree better in the terminology section. Tree node. A node is a structure that contains a key or value and pointers in its child node in the tree data structure. Here we have the syntax to define the tree node. This structure is commonly used in implementing binary trees and related data structures, where each node has some data and references to its left and right child nodes. The struct node defines a structure named node. Int data declares an integer variable data to store the data of the node. The next line declares a pointer left child of type struct node asterisk, which points to the left child node of the current node. The next line we have struct node asterisk right child. It declares a pointer right child of type struct node, which points to the right child node of the current node. Next terminology is root. In tree data structure, root is the first node of the tree. The root node is the initial node of the tree in the data structure. In the tree data structure, there must be only one root node. Edge. The connecting link of any two nodes is called the edge of the tree data structure. In the tree data structure, n number of nodes connecting with n-1 number of edges. Next terminology is parent. The node that is the predecessor of any node is known as the parent node, or a node with a branch from itself to any other successive node is called the parent node. In the tree data structure, A, B and C are the parent nodes. The remaining nodes are the child nodes. The next terminology is child. The node, a descendant of any node, is known as child nodes in the data structure. In a tree, any number of parent nodes can have any number of child nodes. Similarly, every node except the root node is the child node. Here B and C are children of A and D and E are children of B. Similarly, E and F are children of C. The next terminology is siblings. In trees, the nodes that belong to the same parent are called siblings. Next, leaf. Trees in data structure, the node with no child is known as leaf node. The leaf nodes are also called external nodes or terminal nodes. Here, D, E, F and G are leaf nodes. Next terminology is internal nodes. The trees in data structure have at least one child node known as internal nodes. The nodes other than leaf nodes are called internal nodes. Sometimes root nodes are also called as internal nodes if the tree has more than one node. Here A, B and C are internal nodes. Next, degree. The total number of children of a node is called degree of the node. The highest degree of the node among all the nodes in a tree is called degree of tree. Here degree of A, B and C is 2 and the degree of D, E, F and G is 0. The next terminology is level. The root node is said to be at least at level 0 and the root node's children are at level 1 and the children of that node at level 1 will be level 2 and so on. Next terminology is height. The number of edges from the leaf node to the particular node in the longest path is known as the height of that node. The height of the root node is called the height of the tree and the tree height of all leaf nodes is 0. The next terminology is depth. Many edges from the root node to the particular node are called the depth of the tree. In the tree, the total number of edges from the root node to the leaf node in the longest path is known as the depth of the tree. In the tree data structure, the depth of the root node is 0. The next terminology is path. The sequence of nodes and edges from one node to another node is called the path between those two nodes. The length of the path is the total number of the nodes in a path.